I just want to make sure I understand all the pieces in this modern AI architecture. So I have a corpus of data, whether that's my company's, private corpus of data, or that's the whole of the internet, or whatever it is. So I have some data set. I pass that through a transformer. That transformer generates vectors. I store those vectors into a vector database, and that is a LLM, like that. All of those vectors that are stored in the database, is that what you would call the large language model?
So no, the vectors themselves are just representations of the original pieces of text. And then the large language model typically, so once you get everything stored as vectors, the next step for retrieval to say, okay, I stored all of my documents as vectors, I turned them into vectors, I've stored them in my vector database. And then a user comes in and types a question on your search box. And you do the same thing to that question. You pass it through the same transformer model. It creates a vector out of the question. And then the vector database's job is to say, okay, given this query vector, what are the 10 vectors that are most similar to it? And that would be equivalent to showing you the top 10 search results. You get those vectors back. Obviously, you reference back to what the original text was because no one wants to look at a vector. It's just a string of numbers. That is the retrieval model for getting relevant content back. And then you would pass that into the large language model, or you would pass maybe the top document into the large language model, because there are limits to the amount of context you can send as part of the question. And it's probably part of the nuance of all of this stuff is that actually the transformer that creates the embedding, that's actually also a large language model. In true terms, it's been trained on a lot of language, and its output just happens to be an embedding rather than a bunch of sentences, which is what the output of a model like GPT is. The difference, or at least the terminology that I think people are kind of standardizing around, is like large language model have been around for a long time. You can use them for a lot of different types of things. They're of very, varying sizes. GPT-3, GPT-4, Bard, Llama, those are really foundation models. Those are these models with, billions of parameters, where you could have an embedding model that doesn't have anywhere near that number of parameters. It's 4 gigabytes or 8 gigabytes of RAM to run the thing, as opposed to several terabytes of RAM. So while they're all large language models in the end, in a technical sense, ultimately the output ones, the ones that you're using to like generate a really long prescriptive answer, typically is what I would call a foundation model. And that's where the kind of people are talking about who's going to be building foundation models in the future. Is it only going to be the largest companies out there, or are startups going to be able to catch up? How much money will they be able to spend?
Because it requires so much GPU time to do it.
Exactly. Yeah. And it's really the training, right? The training part is where the GPUs are so important. Once you've got everything trained, executing these models, sometimes for some of the really large ones, obviously you want to execute on GPU, but you can execute, typical like embedding transformer model on CPUs very ably.